Hello everyone, I'm Tracy Derwin and I'm here with Shane Buell. In today's video, we're going to be going over the first EF5 tornado in the US in 12 years. And then he's going to be sharing some information of tornadoes that have happened around the world in areas that normally don't see this kind of activity, such as Italy and Japan. So thank you, Shane, for putting this presentation together, and I'll let you share what you found.
All right. Thanks, Tracy. So the big news in tornado world is the fact that there was a tornado which has recently been upgraded to EF5. So back in June 20th of 2025, there was a tornado in Enderlin, North Dakota. Now, this is one of the several like derecho and tornado outbreaks that we've had over the summer. I wasn't actually watching this one live when it happened, but it has since been upgraded based on some damage. So I'm just going to go through some statistics here. So the National Weather Service has finished their survey on the Enderlin #1, which was now an EF5 tornado, and they have estimated the wind speeds to be greater than 210 miles an hour. It was 12 miles long and about a mile wide, and it was on the ground for 18 minutes. Now, what has earned it the EF5 rating is these train cars that were actually derailed. So now these were grain cars that were full of grain, and they were actually pulled some distance from the track. Now these were fully loaded, and the one in the background was actually an empty one. And originally this was assigned an EF3 rating because they don't really have that many train cars to compare it to with other tornadoes. Here's another view of the grain cars that had been tipped over, and these were fully loaded and very heavy. Now, here is the empty one that is out in the middle of the field. This is over 100 yards away, probably 140 to 150 yards away. And there's not really a lot of marks here. Some people have said it rolled into this position. Some people said it was lofted into this position. But you can see the roll marks, but we also have some video that show that the roll marks don't actually go that far. So it was probably lofted most of that distance and then landed and then rolled a short distance from there. I do have some video that I want to show of this tornado. This is captured by a ring camera, and you can only really see it while the lightning flashes, but you can see just how large and massive this tornado is. This is about as big as they get and about as strong as they get. And yeah, that's a very massive looming tornado there in the distance. You don't usually get to see ones like this strong at night or as far north as this one has occurred. So this is the strongest nighttime tornado, and it is also the northernmost of the EF5s, having occurred in North Dakota, which doesn't usually get strong tornadoes like that.
Maybe just explain for people less familiar why they happen at night and in certain areas more frequently.
Okay, so normally the temperature has to be above 55 degrees Fahrenheit for a tornado to occur. The dew point also has to be above 55 degrees. And that normally only happens in the spring and summer months in some of these areas. However, it's less likely to happen at night. So a tornado or even a strong tornado is much more likely to happen during the daytime than it is the nighttime. Now, there are some areas of the United States, such as Dixie Alley in the southeast, that do have nighttime tornadoes as being more common, but that's because they're so far south and the nighttime temperatures typically stay above 55 degrees.
Okay.
Okay, so now I want to show some video of the damage here. This is, again, the train car. You can see just how far the train cars were pulled away from the track, and the other various train debris has been strewn around. But then over 100 yards away, you can see this other train car has been thrown even farther. Now you can see that there's very few marks until right about there. So it looks like it was probably lofted until about 20 or 30 yards from where it landed, and then it rolled maybe another 20 yards. So the reason that this has now earned an EF5 rating is because the math has been done on these train cars. So the calculations have been done for a train car this size. They have done it depending on an empty tank and the distance that it was thrown. And they came to a conclusion of 264 miles per hour. Now, this is probably the top end. National Weather Service has admitted to this being at least 100 or 210 miles per hour, but it could have been as much as 264 miles per hour to move that empty train car as far as it did. All right. And then there are some other damage indicators that I want to show besides this train car, which is laying out in the field. And you can see there's not very much of a mark where it rolled. So I figure it only rolled about 20 or 30 yards. They also had found this tree, which had been completely uprooted and thrown some distance. They actually couldn't determine where the tree originated. They actually spread out in hundreds of yards in each direction to find the tree's original location. They could not locate where the tree came from, and so they don't have an actual measurement on how far the tree traveled or how high the wind speeds would have to be. So that's why they basically didn't have the contextual indicators to determine that this was an EF5 until the math came in on the train. They did have several homes that were wiped clean. You know, they were slabbed basically, and they were taken completely off of their foundation. However, as the National Weather Service investigated these homes, it turns out that none of them were actually well built to the point where they had sill plates with anchor bolts. So they could not determine a higher rating based on the structure damage. So that was the damage that was done in North Dakota, in Enderlin, North Dakota. And we have seen a few tornado outbreaks recently. The last one that I watched was July, so it was about a month after this one, which had occurred in South Dakota actually. And I was able to watch that one live, and I was able to catch some of the satellite shenanigans that were going on. They usually only archive about an hour or two of footage, so if you don't catch it within the first 2 hours, then you're going to miss it if anything suspicious happens. So now this is South Dakota in July. You can see there's like 3 large convective cells that spring up there at the bottom of the picture. I will zoom in here in a second so you can actually see these wave patterns that are coming off of the right side of the tornadoes. Now, it is actually relevant that these are actually trailing off of the right side of the tornado because there could be some technology involved, which I'll get into in just a minute. I want to show one more clip of this particular event. This is the one from South Dakota in July. And you can see these 3 large convective supercells that spring up from an area where these wave patterns are being directed. And you can see to the right edge of these supercells that there are some wave patterns coming off of there. All right, so now those wave patterns could be indicative of sound waves and or 5G next red tower emissions because they do look like an interference pattern. And I do want to actually show a patent, a hurricane and tornado control device. So this is a patent from over 20 years ago that discloses a method for affecting the formation and or direction of low atmospheric weather systems. And they use audio generators, which are positioned to project sound waves toward a peripheral area of a weather system. The sound waves are generated at a frequency to affect the formation of the weather system in a manner to disrupt, enhance, or direct the formation. One of the images I wanted to show is one that we have shown before. This image actually depicts them directing these sound waves at what appears to be the right periphery of a cyclonic vortex. Now, in the northern hemisphere, a cyclonic vortex will rotate counterclockwise, and directing such sound waves at the right side, at the right periphery of a vortex like this, would actually increase the counterclockwise rotation of the vortex. Now, I do have some science that I want to go into as to how this works. So it says here, sound pressure from a long-range acoustic device can create pressure waves that may influence local air movement, potentially affecting the speed of an approaching wind or air mass. When a long-range acoustic device, or LRAD, generates sound, it creates high-pressure sound waves that can displace air particles. And I do believe that an LRAD type device would be the most effective when employed in the manner depicted in the patent. So the sound wave device that they allude to in the patent could be accomplished by an LRAD acoustic device. These LRAD devices were actually developed as defense on the open sea. So to prevent piracy, the American Technology Corporation, which was rebranded to LRAD Corporation in 2010 and later to Genesis in late October 2019, created and developed this device, which included the launch of its proprietary long-range acoustic device, which was an acoustic hailing device. But using this new technology, it became possible for naval personnel to contact approaching vessels which did not respond to radio calls from a distance of over 3,000 meters or almost 10,000 feet. All right, so these long-range acoustic devices have been developed by a corporation which is now called Genesis. And it is the one and only Genesis, the same exact Genesis that is involved in protective communication. So they are the same company that does the alerts for storms and for fires. And they probably have a conflict of interest when it comes to not only alerting people to these kind of weather events, but they also create the technology that could influence these type of weather events as well. One of these pieces of technology is the Genesis 1950 XL. So now this one is actually capable of reaching over 5,000 meters, which is over 16,000 feet. So that's a range of about 3 miles. All right, so now I want to get into sound pressure and how it can affect wind speeds. So since sound attenuates with this distance, extremely high outputs are required to achieve the required range. The acoustic level of the source is commonly expressed in terms of sound pressure level, or SPL. Now, sound pressure itself is an acoustic pressure, which is the local pressure deviation from the ambient atmospheric pressure caused by a sound wave. The SI unit of sound pressure is called the Pascal. Now, here is some math that is done on particle displacement. I just wanted to show that, there is some sound science behind sound waves being able to actually displace air particles. So, for example, if you have an oncoming air mass, such as a hurricane or a tornado, you can actually aim this long-range acoustic device, which is a phased sonic array, which can create very narrow beams of sound waves instead of very conical beams like you would expect, and it can direct them at specific locations. So if you hit the right side of a cyclonic vortex, it would increase the wind speed. And if you hit the left side of a cyclonic vortex, it could actually decrease the wind speed and potentially even wind shear the tornado. So I do believe that something similar to this is what happened with Hurricane Milton, where it was Category 5, but then as it got closer to the coast, it started to break up. And it looks like some sort of wind shear was employed against Hurricane Milton. And the same kind of wind shear could be employed against tornadoes as well.
Do you think just because, when I hear this, I think about like the pyramids, do you think this type of technology can even move physical objects on its
Actually,
own?
yes. Sound waves have been demonstrated in the laboratory to be able to levitate smaller objects. And probably depending on the amplitude or the frequency, that could be modulated to lift larger objects as well. So I do believe that's an extremely viable possibility. Yeah.
Okay.
All right. So as far as these LRAD devices and their ability to influence rotational storms, I did want to show something that I had found where you can see these waves. This is the water vapor images. They don't always show up in the cloud cover. Sometimes you can actually catch this happening in the water vapor images as well. So what we see here at the bottom left are some wave patterns that are perpendicular to the direction of travel, indicating that this could be being used to create wind in that direction to the northeast. Now, one thing that I do want to show here is these tornadoes in East New Mexico as they head into Texas. This was also over the summer, but you can see these wave patterns are also present again during the period of intense convection that led to a tornado, which crossed from New Mexico into Texas. But now that you know what to look for, you can see those wave patterns along the right edge of the storm, which seems to me to indicate that either a radio wave or a sound wave was directed at the right edge of this tornado to help spin it up. Now, if
And
they were directing it at
I saw
Mhm.
them kind of surrounding on both sides of the convection.
Right, yeah, so when you see a general field of lines like that, normally, what's going on is the wind is being pushed in a direction perpendicular to those lines, and
Mm.
that's often what we see during derechos. I will go ahead and show this real quick. So during derechos, we will sometimes see wave patterns like this that actually show up, but on a large scale. So this is one of the derechos that happened last year, and as it moves through Kansas, you can see, or Dodge, I believe this is Iowa actually, but to the right of this storm, you can see these wave patterns that are showing up in direct reflectivity. I believe what was going on is something caused the precipitation to bunch up in these parallel lines, and it was most likely emissions from an XRAD tower or some sort of LRAD device. Now, I think when we see them on a large scale like this, it's most likely NEXRAD, but when we see them on a small scale, it's most likely acoustic. And then this is also very similar to the wave pattern that we saw on Maui during the wind event that they had during the fire on August 8th of 2023. So this is a very similar pattern to what we've seen before, and it looks just like the interference pattern of what's called a plane wave interference pattern, which can be caused by a phased array. And it doesn't matter whether it's a microwave phased array like NexRad or a sonic phased array like LRAD. So that basically covers the tech behind the tornadoes and what to look for. So when you see those kind of wavy lines during a derecho or a tornado event, it's sometimes a sign that this could be manipulated. Because normally what they call gravity waves, atmospheric gravity waves are the term that meteorologists give to this phenomenon, but they say that they're created naturally by wind blowing over the contours of like a mountain range. But when we see this over the ocean, like we did during the Maui fire, it's actually very suspicious because there is no mountain range over the ocean. It's usually pretty flat. And so the presence of those waves is most likely unnatural in that case. And in many others.
What we can do is a link in the description and maybe in the end screen, Bruce, how he explains those patterns. He's been like monitoring this for many years, and how he's never seen that wave or those cloud patterns over Hawaii ever until the day of.
Right. Yeah, Bruce Douglas has been watching the weather daily over the islands for at least 14, 15 years. And he said that that's a very rare event. And I do believe in Hawaii, it is a very rare event to see that. So I do believe that Bruce is spot on with that. Okay. So now we're going to shift gears a little bit and go into what I call the Tornado Alley World Tour. So Tornado Alley does encompass the entire blue area. However, it is expanding and it is moving slightly. So Canada, for example, is starting to see tornadoes farther north than what they used to. Canada doesn't usually have very many violent or strong tornadoes, but they have started having more of them recently. The red area was previous tornadoes, and the yellow area is the newer tornadoes. So not only are they starting to spread farther north, but they are spreading farther to the west as well. And even places like British Columbia are now seeing tornadoes when they didn't really see them before. Also in Europe, the EU is seeing tornadoes to the point where tornado forecasts are becoming a more regular thing now. So tornadoes used to be once in a blue moon in Europe, but now they're actually conditions have favored tornadoes so much so that regular tornado forecasts are becoming a thing. And it's almost looking like EU could have its own tornado alley soon as well. Not only in the EU have we seen tornadoes, but there has also been a tornado this summer in Japan. This was in the western Shizuoka prefecture in Japan, where they had a violent tornado that actually did a lot of damage. And not only are violent tornadoes rare for this area, but tornadoes in general are practically unheard of when it comes to Japan.
Yeah, and I did look up really quick the history of tornadoes in Japan. And this tornado is the strongest in recorded history. This one that happened in Shizuoka prefecture is the EF3. So it's a record for the country. I think that's,
yeah.
And it's probably because Japan is a very mountainous country. I mean, it's basically a big mountain range. So it just doesn't seem like an area that could generate a strong tornado like that, right? And you need to kind of have a plane, right?
Not necessarily. So the ground terrain, like the topology or topography of the ground, does make some difference. So you will actually have tornadoes more likely to happen in plains areas. However, they can still happen in mountainous areas. It's just that the terrain does tend to break up some of the surface level winds. However, a full-on tornado isn't just a surface phenomenon. It's a phenomenon that extends all the way up into the upper atmosphere.
And I'm just kind of noticing a pattern. I don't know if it's because we don't get reports out of certain parts of the world, but these are all NATO countries, right? US, Italy, Japan.
That is true. And yeah, we also have one that I want to show from Italy, actually. So these are some tornadoes that were in Italy as well. And so this is not something that Italy normally experiences, nor does the rest of the EU, especially something where you can see 3 or even 4 of them in one view like this. So there's 3 there, then there's another one to the left that's forming. And so it looks like very anomalous weather, not just for the United States, but for the EU and Japan as well. I do want to leave us with one more video so that goes into how the 5G networks can actually steer storms around. And this is a video that Dane Wigington did after Hurricane Helene, and I'm going to show that now. All right, so here you see the Hurricane Helene coming up through the Gulf Coast into Florida, and then you see all of the NEXRAD towers on the eastern half of the United States sort of light up. Now, these actually do have a repelling effect on air masses and storms themselves, especially if they've been injected with stratospheric aerosol injection of aluminum. And so you can see that it almost acts like a guardrail to keep the storm in its lane. So where you see these NEXRAD towers like energized, they're actually repelling the storm. And it actually creates almost sort of a guardrail as the storm comes up north to keep it from going too far west. So it's almost like it's guiding the storm along the eastern coast there. And yeah, so shout out to Dane Wigington for making us aware of the fact that these NEXRAD towers do have a repelling effect on air masses, and they can be steered around like this. All right.
And just because I mentioned these, we mentioned these two videos. Do we remember which video we did that Bruce explains that? Just because we've had so many videos.
It was either one of our Hurricane Helene videos or one of our Hurricane Milton videos. I can actually dig through and put that in the description below.
Okay, we'll try to put at the end screen and the description, and then also Dane's full presentation. We'll look for that one too and put that at least in the description. And then we also have so many tornado videos now. We have a playlist that we could also include because it does seem like not just in the US, but there's just this, I guess, a worldwide outbreak of damaging tornadoes. And what do you think? Do you think these are all intentional? Do you think it's maybe a side effect of, other changes in the climate?
I don't think all tornadoes are intentional. However, I do think that there are signs that some of these were. So, like the tornado outbreaks in the Dakotas and the other ones that we saw in Mexico and, well, New Mexico and Texas, they do have the signature of being manipulated. Now, those tornadoes were probably specifically manipulated for some sort of purpose. However, I do think that when it comes to like surface temperatures and everything being much higher, recently, I do think that that is also intentional, yet also more of a blanket type of effect where it's happening all over the place and not necessarily being done intentionally in any one spot, but it is being done intentionally over a wide area.
So do you think the origin of it is intentional, or do you think maybe, they're seeing these kind of develop and then they hit it with that energy to intensify it more like
I
that?
do think that they are capitalizing on existing conditions that they may be natural pre-existing conditions, but then they alter and influence those conditions, in their favor, especially in certain local areas. So when you see the right side of a tornado on satellite and there's those wave patterns going at it, it looks like they are intentionally modifying that specific tornado for whatever reason.
And then the Joplin one, the EF5 that sat over Joplin for like 30 minutes that was very unusual, right? For it to sit that long.
Yeah, 30 minutes is a long time for any storm to sit in one spot. Usually when a tornado stalls out, it does what they call a drunknado. It'll do these little loops, but it's usually occluding or weakening when it does that. You don't usually see that with, the average strong tornado. However, when you have tornadoes like Joplin or like this Enderlin EF5, it actually did start to do a loop, which, when it's doing a loop, it's coming back around to a place that it already crossed before. And any particular structure that has already been hit by a tornado would be even more weakened by being hit by the second time that the tornado loops around. So whether it stalls in one place or whether it loops around, it's definitely going to cause more damage. And it is kind of a rare phenomenon. You don't usually see that happen, especially with strong tornadoes.
So thank you, Shane, for putting that information together. I did want to make a couple of honorable mentions because we've been a little bit behind on our weather content. There I think there still is a massive fire going on in Washington in the Olympic National Forest, which is like a national treasure. You know, a lot of people go there and camp and hike and everything. And we have a viewer that was reporting a lot of very unusual things going on, like before and during. So I'm going to kind of look into that a little bit more. And then you also mentioned an unusually strong storm in Alaska, like a
Yeah,
cyclone.
it looks like some sort of extremely strong cyclone has struck the western islands of Alaska. And I don't have a lot of information on that now. It looks like not a lot of people are talking about it, but it is a big event that does need more coverage.
Yeah, I think that Charlie Kirk and Israel is kind of just taking over the news cycle. But I do want to kind of come back to, you know, what we normally do and get back on track on that. So we will be doing that going forward. So thank you guys all for watching, and we will see you all soon. Bye.